Hey everyone, ready to dive into a world where machines learn like our brains do?
I'm excited.
Today we're tackling the Transformer.
Ah, yes. The Transformer.
This revolutionary neural network architecture has been making waves in AI.
Absolutely.
We're going straight to the source for this deep dive.
That's good.
The groundbreaking research paper, Attention is All You Need.
A classic.
This paper completely changed how we see machine translation and so much more.
It really did. It's incredible how this paper from 2017 predicted so much of what we're seeing in AI today.
Right, like they cracked the code for how machines can truly understand the relationships within data.
Exactly.
Okay, so before we get too far ahead, let's take a step back.
Okay.
For those who aren't AI experts, what was the situation before the Transformer came along?
Well, back then, the big players were recurrent neural networks, or RNNs as they're known.
RNNs.
Yeah, they were the go-to for processing sequential data, like language, but they had some major limitations.
Oh, really?
Yeah, think of them like those old dial-up modems.
Yeah.
They got the job done, but they were slow and clunky,
I see.
especially when dealing with longer sequences.
So if you wanted to translate a whole book, you'd be waiting forever.
Pretty much. And even then, the results wouldn't be that great. These RNNs, like the LSTMs and GRUs, struggle to capture the nuances of longer texts. They couldn't make those long-range connections that are so important for understanding language.
So that's where the Transformer comes in with its attention mechanism.
Exactly.
So what's so special about this attention thing?
Well, think about how we read.
Okay.
We don't just process each word in isolation, right?
Right.
We're constantly referring back to previous words,
Yes.
making connections and building a mental map of the sentence as we go.
Uh-huh.
That's exactly what the Transformer aims to do.
So instead of just going through the data step by step, it can jump around and focus on what's important, like our brains.
Precisely.
Yeah.
And because it can process data in parallel, it's also way faster,
I see.
especially for those long, complex sequences that used to trip up the RNNs.
So it's a huge speed improvement.
Absolutely. Imagine going from dial-up to fiber optic.
Wow. Okay, I'm starting to see why this is such a big deal. But how does the Transformer actually pay attention?
Right. At its core is something called self-attention.
Self-attention?
Yeah. It's basically the model paying attention to itself, or rather to different parts of the input.
Hold on, that sounds a bit self-absorbed, even for a machine. What does it mean for a model to pay attention to itself?
Uh-huh. It's not about vanity, it's about understanding relationships.
Okay.
Imagine you're trying to figure out the meaning of a sentence.
Okay.
You might focus on certain words, compare them to others,
Right.
and see how they connect to create the overall meaning.
Uh-huh.
That's what the Transformer does with self-attention.
So instead of just looking at each word individually, it's considering how all the words relate to each other?
Exactly.
It's like drawing a map of the sentence's meaning?
That's a great analogy. And that's how the Transformer can understand those long-range dependencies that stumped the older models. It can see how a word at the beginning of a sentence might be crucial to understanding a phrase at the very end.
Wow, so it's like the model is building this multidimensional web of connections between words.
Yes.
Capturing all the subtleties of language.
Right. And that's why this paper was such a game changer. It wasn't just a faster model. It was a completely new way of thinking about how machines process information.
Okay, this is all pretty amazing. But there's one thing I'm not sure about.
What's that?
If the Transformer isn't processing data in order, how does it keep track of word order? I mean, dog bites man is very different from man bites dog.
That's a great question.
Yeah.
You're right. Word order is crucial, and the researchers knew that
Yeah.
to solve this, they added something called positional encodings to the input.
Positional encodings, what are those?
They essentially give each word a unique tag,
Okay.
indicating its position in the sentence without disrupting the parallel processing.
So even though the model is processing everything simultaneously, it still knows which word comes first, second, and so on.
Exactly. And it's not just about basic grammar. This positional information helps the model capture subtle nuances in meaning that depend on word order.
Wow. The more we unpack this Transformer, the more impressive it gets. Can't wait to dig into how this attention thing plays out in the real world.
Me too.
But I think we'll save that for part 2.
Sounds good.
Okay, so last time we were totally geeking out over how the Transformer uses its attention mechanism,
Right.
making connections in data almost like a super brain.
Yeah.
But how does all this translate to the real world?
It's not just theory.
Right.
Transformer has had a massive impact across many fields.
Okay, I'm intrigued.
Yeah.
But before we go there, I have a question.
Sure.
You mentioned impressive results in machine translation.
Uh-huh.
Isn't that kind of expected? It's in the title of the paper, Attention is All You Need. I mean, obviously, attention is key for understanding languages.
Oh, you're absolutely right. Attention is crucial for understanding languages.
Right.
But the real breakthrough is how the transformer uses it.
Okay.
It can process data in parallel, making it much faster and more efficient than anything before it.
Okay.
And this efficiency leads to better results.
So it's not just translating faster, it's about translating better.
Exactly.
Yeah.
But the impact of the transformer goes way beyond language.
Really?
This attention mechanism has become a core building block for AI in so many applications.
Wait a second. We were talking about words and sentences.
Yeah.
How does attention apply to images? Images aren't sequential, like language.
That's the amazing thing about it.
What?
The core idea of attention,
Uh,
focusing on what's important, is incredibly versatile.
okay.
When it's applied to images,
Yeah.
the model can learn to pay attention to different regions.
Like we do when we look at a picture.
Exactly.
So instead of looking at every single pixel individually, it can just focus on the areas that matter most for the task.
Right? Like if it's trying to find a cat in a photo, it might focus more on the furry four-legged blob.
And less on the background.
Exactly.
Well-
And it's not just recognizing objects either.
What else?
Think about medical imaging.
Oh, yeah.
Attention mechanisms are helping doctors analyze scans,
Wow.
find abnormalities,
Uh-huh.
make more accurate diagnoses.
That's amazing.
Or in self-driving cars,
Oh, right.
where the model has to understand a constantly changing environment.
That makes sense. What about something like music?
Music.
Yeah. It's sequential, but it's not language.
Right. But it's still a sequence of notes.
Uh-huh.
And the relationships between those notes create the melody, harmony, and rhythm.
Right.
The transformer can use attention to understand those musical relationships.
Just like it understands relationships between words.
Exactly. So instead of predicting the next word,
Yeah.
it could predict the next note in a melody.
Or even compose entire piecing of music.
Precisely. And just like with language, it can capture those long-range dependencies that give music its emotional depth.
Okay, this is really incredible. It's like the transformer is this multi-talented musician. What about something completely different, like drug discovery?
Drug discovery.
Yeah. How does the transformer fit into that?
Well, drug discovery is all about understanding these really complex relationships
Between.
between molecules, proteins, biological processes. It's a perfect field for AI, but the data is so complex.
And that's where the transformer comes in.
Exactly.
So it's not just creative, it's analytical and scientific too.
Absolutely.
Yeah.
The transformer can analyze these huge data sets of molecular structures, research papers, clinical trial data to find patterns and make connections that human researchers might miss.
So it's like a whole army of superpowered research assistants working to solve diseases and create new treatments.
That's a great way to put it. And it's
Oh.
not just finding new drugs.
What else?
It's understanding how existing drugs work, identifying potential side effects,
Wow.
even personalizing treatments
Right.
based on an individual patient's genes.
Yeah. This is really amazing. The transformer is not just a one-trick pony. It's like this universal tool for understanding complex relationships in data, no matter what the field is.
Exactly. And we're only just getting started. The applications keep growing.
Really?
Yeah. Every day, researchers are finding new and innovative ways to use the transformer's attention mechanism to tackle challenges in all sorts of fields, from finance to climate science to robotics.
So what we're seeing is the transformer isn't just a technological thing. It's a paradigm shift in how we approach problems.
I think so.
It's about understanding relationships, making connections, seeing the bigger picture.
Absolutely.
So we've covered a lot of ground here,
Yeah.
from the inner workings of the transformer
All right.
to all its real-world applications. But I have to ask, what's the bigger takeaway?
I think the transformer isn't just a technological marvel.
Okay.
It represents a huge shift in how we think about processing information.
So it's not just about the tech, it's a philosophical change too.
Exactly. The transformer, with its focus on attention and relationships,
Yeah.
it really mirrors key concepts in cognitive science.
Well, how so?
Well, it suggests that understanding information
Uh-huh.
isn't about linear processing,
Okay.
but about making connections, seeing patterns, building a big picture understanding.
So it's almost like the model is reflecting how our own brains work.
That's a fascinating thought.
Right.
We're not saying the transformer is a perfect replica of the human brain,
Of course not.
but the similarities are really interesting.
Yeah.
The way it focuses selectively,
Uh-huh.
connects distant elements, constructs meaning.
Right.
It resonates with some cognitive theories.
That's really cool. And this new way of thinking, has it had any real-world impact?
Absolutely. Moving away from step-by-step processing, the transformer unlocks the power of parallel computation.
Like our brains.
Exactly. This has huge implications for the future of AI.
Especially as we develop more complex models.
Yeah, certainly.
It's like we've found this whole new level of computational power.
One that's more in tune with the natural world.
That's a great way to put it. The transformer isn't just about crunching numbers faster.
Right.
It's about understanding information in a holistic, interconnected way.
So where do we go from here?
That's the big question.
What happens when we combine this new processing power with the ever-growing amounts of data and computational power we have?
That's what researchers are trying to figure out.
Right.
We're already seeing glimpses of what's possible.
Like what?
AI models creating realistic images, writing creative text, even contributing to scientific discoveries.
So we're entering a new era of AI-powered creativity and innovation.
It seems that way.
But we have to be careful, right?
Oh, absolutely. With great power comes great responsibility.
Exactly.
We need to be aware of potential biases in these models, the ethical implications of how we use them, and we have to make sure they align with human values.
It's a good reminder that technology doesn't exist in a vacuum.
Right.
We need to think about the social and ethical impacts of the tools we create. I completely agree. The future of AI isn't set in stone.
Yeah.
It's up to us to shape it for the good of humanity.
And understanding the ideas behind technologies like the transformer is essential for navigating this new landscape.
Definitely.
Well, this deep dive has been incredible.
It has.
We've gone from the technical details of the transformer to its mind-blowing implications, and how it could reshape our world.
Absolutely.
To our listener, as you think about the transformer's potential for learning and adapting, consider this. What happens when these models encounter even bigger data sets? More diverse information, more complex tasks.
Interesting.
What will they be able to create?
It's exciting to think about.
And how will they change our world?
It's a future full of possibilities.
Thanks for joining us on this deep dive into the world of the transformer. It's been a fascinating journey.
It really has. Thanks for having me.